Okay, so today what we're going to talk about are z-scores. So let's review. Consider the following data distributions. For each of the following distributions, indicate if it's a normal, approximately normal, skewed, or neither. All right, and then, of course, then you have to, I want you to tell me the reason why. All right, so let's take a look at number one. So number one is normal symmetric. Okay, this is a normal curve. Okay, and the reason why is because it's symmetric. Okay, and notice it looks like a mound. It's mounded shape. All right, let's take a look at B. B is also normal. Okay, it's symmetric. This is also has a mound shape. Okay, notice that C goes like this. Looks like it has a tail, so that's skewed to the right. D would be normal, symmetric. Okay, it's a mound shape. Okay, so now take a look at E. E is symmetric, but it doesn't have that mound shape, doesn't look like this. So this is actually neither, even though it's symmetric. So it's neither even though it is symmetric, because it does not have a mound shape. Mound shape. Okay, so let's take a look at what it says down here. It says a normal distribution is a distribution that has, actually let me move this all up. Okay, so a normal distribution is a distribution that has a particular symmetric mound shape as shown below. So see this shape here, it looks like a mound. It's called a bell curve or the normal distribution curve. Okay, many populations have a distribution that can be well described with what is known as the normal distribution or the bell curve. So something that you always hear them using the bell curve is when someone has a baby, and if you hear someone say, oh, what percentile is your baby's weight in, that when they talk about, oh, my baby's weight or my baby's height is in the 95th percentile, they're talking about this bell curve. Okay, all right, so let's talk about a z-score. Is used when calculating probabilities, measures the number of standard deviations away from the mean, represents a variable that has a standard normal distribution, so we're talking about this curve here, where the mean is at 0, which means it's right in the middle, and is 1 standard deviation, so going to the right 1 and to the left 1 standard deviation. Okay, so let's look at the other side. Okay, so a positive z-score corresponds to a value that is above the mean, and a negative z-score corresponds to what is below the mean. So when you have this mound, right, we have, here's the middle is the mean, right, which is your 0. So 1 standard deviation or a positive z-score would be above. This would be above at 1, and this would be below at negative 1. A z-score is calculated by the value minus the mean over the standard deviation. So you have to know this. So remember I said the other day, make index cards. So put this on an index card so you know how to calculate a z-score. All right, so let's take a look at the examples down here. All right, the prices of the printers in a store have a mean. So I'm going to just put this as X bar of 240, which remember is also your mu, and a standard deviation of $50. The printer that you eventually choose costs, so the value of your printer is $340. What is the z-score for this printer? So your z-score is the value of your printer, which is 340, minus the mean, 240, divided by the standard deviation, which is 50. So that's 100 over 50. So your z-score is 2. Okay, which means it is 2 standard deviations above the mean, because it's positive 2. So it's above the mean. All right, let's take a look at 2. Just going to move everything up a little bit. Okay, so it says, how many standard deviations above the mean was the price of your printer? I just told you. So we have the mean, right, is 240. You paid 340, okay? The standard deviation is 50, right? So from 240 to 340 is $100. So you have 2 standard deviations, right? 50 plus 50 is 100. So you are 2 standard deviations above the mean. That is your z-score, 2 standard deviations. So you paid 2 standard deviations above the mean. Okay, so if you look at the bell curve, right? So in the middle was our mean, right, which was 240. So here's 1 standard deviation above the mean, right? 1 standard deviation would be $50. That would put us at $290. So now we are at 2 standard deviations above the mean. So we're over here at $340. Right, so from here to here was $50 and then another $50, 2 standard deviations above the mean. All right, and let's look at the last one. It says, what percent of the printers are between $200 and $300? Okay, so this is what we're trying to do. So remember back a while ago, we talked about the normal distribution curve. Remember we drew the curve, right? We labeled the mean. Okay, so what I want to do is find what percent is between 200 and 300. So the mean was 240, and I want to find between 200, which would be over here to the left, and 300, which would be over here on the right. So I'm looking for what percent is in between here. So what we did was when we did the normal distribution curve, remember we filled in the percents, but the problem is that these numbers 200 and 300 aren't at nice standard deviations. So what we're going to do is find each standard deviation, the standard deviation for 200, the standard deviation for 300. Those are called your z-scores. All right, so let's find the z-score for 200 first. So the z-score for 200 is 200 minus 240 divided by 50, right? Because it's the value minus the mean. Remember, it's the value minus the mean divided by your standard deviation, which is 50. So when you plug that into your calculator, you get negative 0.8. So that's my z-score for 200. Now we have to find the z-score for 300. So that would be the value 300 minus the mean, which is 240, divided by the standard deviation, which is 50. So you plug that into your calculator and you use 1.2. So this one over here is 1.2. So we have a negative 0.8 standard deviations to the left and a 1.2 standard deviations to the right. So you can see these are not numbers that are on our bell curve with all those percents. All right, so then how do we get this percent here that's in the middle? Well, what we're going to use is the calculator. So if you don't have your calculator in front of you, you need to get it. So put me on pause and get your calculator so you know how to plug this into your calculator. Okay, so what I want you to find is the distribution button on your calculator. The distribution button is right above the VARS button, and the VARS button is right next to the clear button. So put me on pause and take a look for that. So we're looking for the distribution button. Okay, looks like that. All right, so press, so you do second and then VARS, that's the distribution button. All right, and then you want number 2, which is normal CDF. So press that. All right, and then it comes up lower number. Your lower number is your smallest standard deviation, which in this case would be negative 0.8. So type in negative 0.8 and then hit enter. And then you're going to do upper. And then that would be your larger standard deviation, which is 1.2. So type in 1.2, enter. Now, the mean, since we're using z-scores, you're just going to leave at 0 because your standard deviation for the mean is at 0. And your mu, that's your standard deviation, is 1. So we're labeling that it's going by 1s. And then you're going to press paste, so just hit enter. So hit enter. And then it'll come up on your screen. It'll say normal, if you did it right, CDF, and it'll say negative 0.8, comma 1.2, comma 0, comma 1. Okay, hit enter again, and you will get 0.673074938. So I want to know what's the percent. So I take the decimal, move it 2 places to the right. So it is approximately 67.3%. Okay, so now that's how you plug it in with your standard deviations. There is a way to plug this in by just using these values here. Just by using 200, and 300, and you have to have the standard deviation and you have to have the mean. Okay, so that's what I'm going to go over now. Okay, so again, I'm looking for, here's my curve, my bell curve. Remember, the middle is the mean. My mean was 240. And we're looking for in between 200 and 300. I'm looking for this percent under here. All right, so I'm going to show you how to plug it in your calculator using 200 and 300, the mean. And you also have to have your standard deviation, and your standard deviation was 50. Okay, so same thing, you're going to press distribution. Okay, so press distribution button again. Same thing, you're going to go to number 2. That's the normal CDF. Okay, so 2. And now your lower number. Your lower number will be 200. That's this guy. It's your lower bound. Your upper bound, so type in 200, press enter. Your upper will be 300. That's how high you want it to go. Your mu. Your mu is your mean. And you're going to type in 240. And now you're going to type in your standard deviation. So your standard deviation, right, so that's this guy here, right, standard deviation is 50. So type in 50. Press paste, and then again, it'll come up normal CDF, and you should have 200 comma 300, comma 240, comma 50. Okay, press enter. Press enter, and you'll get the same number. You're going to get 67.67307, same number that we got before, which is approximately 67.3%. So how do you, which method to use? Well, it depends on what information you have. If you have z-scores, standard deviations, then you want to use the first way. And the only difference with the two ways is one is you're putting in the standard deviations in lower and upper, but your mu has to be 0 and your standard deviation has to be 1. Now, if you have actual data, like what I just did here, okay, like I had data, 200, 300, standard deviation and the mean. Then you use this way, where you put in your actual data and you actually plug in the mean and the standard deviation in for mu and sigma. Okay, so you're going to give the worksheet a try. And I hope you guys are doing well, and I will hear from you later.